Assalamu alaikum students. And today's class, let's study about division of integers. Okay, let's see how to divide. What is the sign? Already we have seen the rules of division of integers. What it is same as that of multiplication, right? So what if you have both the integers dividing with the same sign? Okay, so what is the output for this both? You will have the output plus output integer after dividing the two integers, okay, with positive sign and two integers with negative sign. So your output integer resultant integer will be positive. And if one on the numerator, if you have in the numerator, if you have positive, negative, or numerator we have negative and here positive, then you are going to, that is, get the output, resultant output, in terms of negative integer. Okay, so this rule is same as in multiplication. So what are the rules for multiplication? If we have two integers for multiplying which are both are positive, then output will be positive. If both are negative, again output will be positive. So the same sign integers when multiplied, you will get positive. Okay, one is positive and the other is negative, then the output will be in terms of negative, that is, it will be negative integer. Okay, we had seen this in multiplication. We all know that division is just the inverse operation of your multiplication, isn't it? Let's take one example. We have 3 cross 5. Okay, this is nothing but what? 5 3s 15, isn't it? So if it is, therefore it's nothing but, if you take 5 this side, okay, this is 15 divided by 3 or 5. Okay, let's take 3. Here it will be 5, isn't it? 5 is equal to 15 by 3, or 3 is equal to 15 by 5, right? Division is nothing but, it's just an inverse of operation of your multiplication. So that is why the rule for the integer sign output will be same. Okay, let's see some of the statements or examples for your integer multiplication, sorry, integer division. All right, see, we have here one multiplication example. First, here 2 cross minus 6. 2 multiplied by minus 6 is equal to how much? 6 2s, it is 12, and since it is plus 2 and minus 6, so your output will be minus, right? Okay, now for division, you can, it is same. Okay, so let's say minus 12 is divided by 6 minus 6, this is equal to what? Plus 2, isn't it? At the same, yes. So it's just a reverse operation of multiplication. Or you can write the same equation in terms of division, like minus 12 divided by 2 plus 2 is equal to how much? See, this is minus and this 2 is plus. So what is the answer? It is minus 6. See, this is same as this. Okay, so it's division is just the inverse operation of your multiplication. Okay, now let's see division on the integer number line. Okay, how to find your division answer on the number line. Okay, this is, suppose, let's take this example. 12 is divided, minus 12 divided by 3, we get minus 4. Okay, since multiplication is reverse of division, so you can write this in this way. So 3 cross 4 minus 4 is equal to minus 12. So in multiplication, how do you draw? You need to draw first 3 hops. Okay. This is, so if you start from here 0, you are taking 3 hops in the opposite direction, because here the steps are how many is minus 4. If it was 3 cross 4, then you would have moved forward. Okay, from 0, 3 1 hop will be till 4. Okay, since this is minus 4, so it is moving from 0 to minus 4, first hop, second hop, and third hopping or jumping. In each jump you have how many steps? You have minus 4 steps, right? 1 2 3 4. All right, so these steps is nothing but your division answer. All right, so in this way your multiplication, you can get the answer from your this, what you say, number line, integer number line. You can get the output or understand in this way. These steps is nothing but your division. Okay, answer for your division, isn't it? So steps are how many hops? It is 3, and each hop will have division of minus 4. So this is your minus 4. In a previous class video, we had seen this multiplication of integer number line, right? From this, see how exactly your division. See, this is you by hopping, okay, 3 times it had reached 21, right? So 21, when it is divided by how many? 3 hops. Okay, what is your answer? It is 7, right? So plus 7. So what is the division between the in this hop will give you the answer. Okay, if you are talking about in terms of division. This was for your multiplication of integers, what we had seen before. Tell me what would be this. If you take by hopping 10 times, okay, it had reached 20. So 20, when hopping how many times? Hopping it 10 times. Okay, what is the answer? How many divisions you have in between here? Steps, it is 2. So 2 is your answer from the number line, isn't it? Okay, tell me for this now. The hopping 4 times, it reached 16. Okay, so you are at 16 now. 16 when hopped 4 times. So what is the answer? It should be 4, isn't it? So each this hop is of divisions of 4. Okay, so just since multiplication and division are inverse operation, this is the way you need to just understand on the number line. So now it's time for us to study the properties of integers. Okay, under addition, under subtraction, under multiplication and division. Okay, so under all these operations we need to study the properties. In the last 6th class, you had studied the properties of whole numbers, right? I hope you remember those properties. Let's see one by one. Before that, students, in your textbook you have many exercise problem for the multiplication. It's very easy, and try to analyze it by drawing on the number line as well. And if you have any doubt how to plot it on the number line, we can discuss that in your online class, okay, on Zoom meeting. Okay, let's move on to the properties now. In your properties, see, I'll just name all the properties first, then later we'll see one by one for all these operations. Okay, you have closure property, okay, then you have commutative property. I hope you remember these properties. You have studied these for your whole numbers, right? Now third is what? Associative. Okay, fourth, identity, or if it is for addition, it is additive identity. Anyway, in general it is identity property. All right, and additive inverse or inverse property, identity, and for some we have added identity inverse. Okay, so inverse property. So you have basically these 5 properties to be learned for each of the operations under integers, that is addition, subtraction, multiplication and division. Now let's see what we will do is, instead of going operation wise, we'll go property wise. So first, closure property, how is it true or no for all these operations, we will see now. Okay, I think today we can complete our closure property for all addition, subtraction, multiplication and division. Okay, so closure property first. Okay, what is closure property, students? Closure property is nothing but any you have a set of numbers. Okay, we had seen that you have natural numbers, then whole numbers, then integers, isn't it? So in this number set, you have so many numbers: 22, 10, 0, then -11, -50, and so on. There are many numbers, okay, in this set. So closure property, in this closure the set, okay, what does say? It says is any number. Let's take A and B number. Okay, so any operation you do, if you do A plus B, or A minus B, or A dot B, and A divided by B, so all these operations, when you do, the output whatever you get, okay, that, let us take it as C. Okay, this is equal to some output C. So this output number, it should belong to this set of, it should belong to this set. Okay, that is closure property. That is it should be now A, B is from belongs to this integer Z. Okay, now if I do operation A plus B, then suppose answer is C, then this C also should belong to Z. Then you can say that closure property is true for addition. Okay, is true for addition. Okay, can you say any example in which this addition will not be true? Say, let me take some examples. 6 plus 3. Okay, let me take this statement. So this 6 belongs to Z, 3 belongs to Z, and the output of this is 9. Even this belongs to Z, isn't it? If I take other scenarios, -10 plus 2. Okay, so what is the output for this? Yes, it is minus plus, so you need to do subtraction, that is you'll get 8. 10 minus 2 is 8. The sign is of your larger integer number. This is 8, so -8, it belongs to Z, that is integer number, isn't it? Therefore integers are closed under addition. Okay, so in the previous year we had seen whole numbers are closed under addition, integers are also closed under addition. So closure property is true for addition. Okay, let's see for under subtraction, about is it closed under subtraction, integers are closed under subtraction or no. See these examples. 9 minus 7, how much is it? It's what? 3 plus 3. Okay, this is minus 3. And 2 minus 1 is what? 2 minus 3 is minus 1. Okay, and 2 minus 2 minus 0 is what? Minus 2. So all these outputs, they belong to integer set, isn't it? So minus 3, plus 3, minus 1, minus 2, all these belongs to number, integer number z. Therefore, this under subtraction also, your closure property is true. Okay, therefore integers are also closed under your subtraction. Okay students, I hope it is clear. There is nothing difficult in this. Okay, now let's see for multiplication. What do you think, students? Will it be true? This closure property is true, will be true for multiplication. See these examples. And 10 multiplied with 0 is what? 0, isn't it? So does 0 belong to z? Yes, it belongs to z. Minus 11 multiplied with minus 8, 11 cross 8 is 88. What should be this output sign? Both are minus, so it will become positive. Plus 88, even this belong to z. Minus 15 multiplied by 2, 15 multiplied by 2 is 30, and the output sign is minus 30 because one is minus and the other one is plus. So minus plus will give you output in terms of minus. So even this belongs to z. Therefore you can say integers are also closed under multiplication. Okay. Okay, now let's see the last operation for division. Will it come true or no? Okay. Take some example. 15 divided by 3. Let's take minus 3. How much is it? It is 5 minus 5, isn't it? So one is plus and the other one is minus. Okay, my plus divided by minus will give you answer in terms of minus. So this belongs to z. Yes. Okay, now tell me the scenario like 2 divided by 5. 2 divided by 4. Let's take 4. You can take 5 also. So 2 divided by 4. What is the answer for this? It will give you again 1 in terms of fraction, right? 1 divided by 4, or you can say this as how much? 0.428, 4 5 20, right? 0.25. Does this belong to z? No. Okay, so this number we can plot 0.5 on the number line. Okay, this is 0 and 0.25. We can plot this, but this doesn't come under your integers. This number belongs to fractions. You're going to learn this in your next unit, further chapters. Okay, so this doesn't belong to your integers. So what do you infer? You have many cases like this. Okay, like you have 1 minus 1 divided by 5. Again this is minus 1 by 5. This is a fraction. Okay, so even this doesn't belong to z. So you can have number of examples, okay, which will give you answer in terms of fractions. Okay, in terms of decimals, this you can say it's in decimal point answer, and this comes under your fraction. Okay, so what what do you infer? Therefore, integers are not closed under multiplication, sorry, division. Okay, under division. So let's stop here, students. In the next video I will go for the other properties, and let's see if our next property is what it is, your second commutative property. Okay, and I hope we can complete those properties in the next video, inshallah. Until then, assalamu alaikum wa rahmatullahi wa barakatuh.